So thank you again for everyone for joining this morning and taking the time out on a Saturday to do this. Promise it'll be worth your while. It's very useful industry tooling. Um, we've used it internally. I've used it in pretty much every security job I've had in the past and a lot just at home as well. I run this at home. Um, for those of you that weren't on the last call that we had for the QA that I was on, I've been at Soteria. Pam on the call is also she's a heads our consulting services at Soteria, and Brandon is a junior engineer at Soteria under I. Um, at home, I run a just a small data center in one of my spare guest rooms, so I have a lot of excess servers and networking equipment. So I'm always open to opening that to anyone who would like to learn and just ever come over and nerd out. I know now is not the best time with the COVID going around and whatnot, but um, Richard, I'm sorry, is also on the call. He's an intern for Stereo. Sorry about that, Richard. And yes, I'm available on LinkedIn. I'm on the Discord chat for Trident Tech. So always feel free to reach out. With any questions. Doesn't have to be just tech questions. I'm always available and always a resource to be able to help anyone out. Um, so Security Onion, it's something that you could definitely spend weeks on learning to fine tune and really get accumulated. So to shove it into a 2 hour session is going to be kind of a lot. If anyone wants to stick around after 12, I will stick around. I'm available for if you want to see something more in depth. Or just have questions about something that we had to skim over rather quickly. There's a lot that's involved in Security Onion. Um, so I'll just go ahead and start with what it is on the docs. So Security Onion, as you can see, it's a free and open source Linux distribution. It's an Ubuntu fork. Basically, it's maintained by, you can see here, Doug Burks. He's a really smart guy, really intelligent. I've talked to him a few times, had the pleasure of doing that on LinkedIn. Uh, really great guy. He actually started Security Onion Solutions. And that's really they do training, professional services, and they sell hardware appliances for Security Onion. And a lot of enterprises actually have distributed Security Onion setups in their environments for intrusion detection system, both network and host based. Obviously, with it being a Ubuntu distribution under the license that it's sold, you can't sell it as a product since Linux is under the GNU license, but you can sell professional services around it, including hardware appliances. Um, so it's awesome to see they have securityonionsolutions.com for a lot more information there around it. But this is just the read the docs page, and this pretty much contains everything about you could possibly want to know about Security Onion, aside from some things I'll go into today, about where things are located on the file system. But basically what it is, it's an Ubuntu fork for intrusion detection, enterprise security monitoring, and log management. Includes the Elk Stack, aka Elasticsearch, Logstash, Kibana, Snort, and Suricata. For those of you who don't know, are network intrusion detection systems. Formerly Bro, now Zeek, also kind of functions as a network intrusion detection system. We'll go into that. Waza, formerly OSEC, is your host-based intrusion detection system. And the rest, Squeal, which is kind of being deprecated, and Squirt are both kind of alert management for the intrusion detection systems, but they're kind of being phased out in favor of the Elk Stack, and we'll go over into all this. There's a ton of miscellaneous tools that Doug has included now in Security Onion, which did not used to be. If you're familiar with what these are, CyberChef is just kind of, and we'll demo all these. It's just kind of a all-in-one kind of Swiss Army knife for like security, like converting binary into hex into any kind of different URL encoding. We'll go into it. It just does a bunch of different things. Network miner for carving out specific things in PCAPs, like executables or JPEGs or whatever kind of argument you do in it. Then there's a ton of other security tools and suites that are included in the distribution. So it's kind of your all-in-one stop for an enterprise security monitoring. And since it's just an Ubuntu fork, you can always install other things on top of it through either your apt package manager or just calling it through a Git repo. So anything that'll run on Ubuntu, and the latest Ubuntu distribution that this is based off of is 16.04. Previously, it was on 14.04, which made it very difficult to build stuff on because it didn't have systemd, which was one of the big things that was introduced with 16. So really anything you can do on Ubuntu 16, if you have a preferred tool set that you want to include with it, or equally take away. It's very flexible in that way. And I'll include these links in the WebEx meeting or in the Discord chat after I'm done here. So basically, once you install the operating system, you just download the ISO, and that's straight from Security Onion Solutions. So just like downloading any other Linux distribution, download it straight from the verified source. In this case, securityonion.net. This will also have additional, screenshots, downloads, or I'm sorry, documentation. They have conferences that go around. They're really popular. There's a ton of training resources around Security Onion, and since it's open source, there's a ton of stuff on GitHub for people that have contributed to it. Other than just what Doug and his team have contributed, there's a ton of third-party stuff that you can integrate with it, and I'll go over some of the more popular ones. But like I said, just like downloading any other distribution like Ubuntu, here's your ISO image, and then as always, when you download it, just verify the hash value on it to ensure nothing was modified in transit or at rest, and then you would just launch that ISO and install it as normal. So, and Brandon, you installed this with me yesterday, so if I leave anything out as I'm going through this, please jump in. So what we're looking for, and I'll start out with two architectural diagrams here, is so where in the network would you place something like this? To run security on is a relatively powerful machine, so it does recommend, and this will increase based on how big or small your enterprise is. If you're running it at home, it doesn't have to be a powerful machine at all, especially if it's just you and a few people. But as you run this in an enterprise business, you'll have to scale up, both CPU, memory, and disk space. But for this purpose, I'll just locate the specs as if we were doing this in a home lab. For my home lab, I'd run servers, so it's a little different. But so essentially, what you have here, we'll walk through the architecture a little bit. So we have your internet providers, router and modem. That goes directly into a switch, which, into that switch, you would have maybe some wired devices, maybe you have some desktops that are physically connected for, gaming or higher speed.
Anthony, can I disturb you for a sec?
Sure.
Yeah, we can't see I can't see the diagram. It's looks like it's security blocked or something.
It's like a gray mesh block.
Yeah.
What do you have open right now, Anthony?
A network architecture diagram. Actually, I think I can just find this on Google. Yes. Okay. Can everyone see this?
Yep.
Okay. Sorry about that. Okay, so zoom in a little bit here. Okay, so yeah.
Hold control and scroll your mouse wheel up. That'll zoom it for you in the browser.
Add a mouse.
Do control and plus symbol.
Yes.
That too.
Yes. Okay. Okay.
Perfect.
Awesome. Thanks, guys. So yes. So open internet here. Your wide area network. This would be your ISP, router, modem, AT&T, Comcast, whatever you have. Go into some kind of managed switch. 8-port, 16, 24, whatever it is. Off of here, you'd have some wired devices. If you have gaming laptops for faster streaming, or you have plugged in IoT devices, for example. And then you just have like a Wi-Fi access point plugged into the switch as well for all your wireless devices. And this is just a mock, architecture. This is not exactly what you have to have. So basically, where security onion lies in the architecture is it's going to be best placed for most networks at your top level switch, which in this case there's only one. We don't have like a distributed switching network where you'd have underlying switches for lots of different networks under here. We just have one, and that's going to be usually in most environments we'll just have one. But at least one top level switch here that'll be connected directly to the router or modem. So for Security Onion, we need at least 2 network interface cards. One of them can be Wi-Fi, although sniffing Wi-Fi traffic is not usually recommended. They're usually, and Doug just recommends sniffing wired. So we need 2, and the reason that we need 2 is one of the network interface cards will serve as the management NIC, or that will be the one that is assigned an IP address. That's how you will communicate with the actual sensor. So that's the one where if you plug in any laptop or anything like that, that's where you will get your IP address and you can access that over the network. The other interface or interfaces will be for sniffing. If you've ever seen on a managed switch, this will be referred to as the mirrored port, or on a Cisco switch, they've coined the term span port. And essentially what that is all of the traffic that is going through the switch will be mirrored to that one specific port. So in this case, whatever port that the sniffing interface is connected to, all of that traffic will then be sent to the sniffing port on the Security Onion server. So for example, if you had Wireshark running on your desktop and your desktop had 2 NICs, Wireshark would, you would plug that into the mirror port. You'd be able to see all the traffic flowing through the switch in Wireshark. In Security Onion, you can have as many sniffing ports as you want. So if you have a server, there's usually 4 NICs. You can install 8 NICs, 12 NICs, however many you want. You just have to make sure that your server has the resources to go up to that to be able to sniff on that many. But for this use case, we'll just go on. We have 1 sniffing port connected to the switch, and then another NIC connected to the switch. That's our actual management interface. And as you can see in the architectural diagram here, the management connection is a bilateral communication. So as anything would be that has an IP address, the sniffing interface is just a one-way. It's a unilateral connection. So this is a one-way traffic flow. So it's just traffic that's going to the mirror port on the switch is all just going straight to the Security Onion server. There's nothing going back out of that mirror port. It's not assigned an IP address. You can kind of think of this as like a crossover cable in the older days where it's just a one-way communication. That's how it is on a mirror port session. Does anyone have a question about port mirrors or like a span port or anything like that?
I'm okay, but I'll leave it for some others to say otherwise.
Sure.
Yep, I'm following. Anybody else?
Good so far.
Awesome. And this is important for this is how we're essentially catching all the traffic and monitoring all the traffic for the network intrusion detection systems that are Security Onion. So let me see if I can get the other diagram up. And this is a better overview on how the operating system kind of works for Security Onion. So how this basically works is, and it doesn't show it all here, but so assuming the traffic is coming in and you have your span or your mirrored port all set up correctly, so now we have all of the traffic that's traversing that switch mirrored and coming into the sniffing port on the hardware that Security Onion is running on. So what does the traffic do and what is Security Onion doing once it's receiving that traffic? So first thing it's doing when it's initially receiving that traffic is it has a tool called NetSniff NG. Essentially, what's NetSniff NG? I'll pull that up for anyone who has not heard of that. But essentially, what that does is it listens. It puts a network interface card into sniffing mode, and it writes PCAPs to disk, specifically for security onion purposes. So a fast network analyzer based on packet mmap, and it stores them raw PCAPs to disk. So in Security Onion does by default, and you can select or modify this however you want, but it does write PCAPs directly to disk. And this is a big advantage, especially if you need a deeper investigation of what just regular, and I'll show you this later, of what ELK is providing you, but if you need a raw PCAP, those are always on disk, and those are great to always go back and reference, not just for like a SOC team to do further investigation, but for any kind of forensics or incident response, that we have that network traffic in raw PCAP format, so we can go seed that and make sure we have PCAPs are going to be as granular as you can possibly get on the network level. So any kind of forensics, we can go back. You can always kind of modify log files. A little bit harder to modify PCAPs. So it's always good to have that as also an integrity check to go back and do further investigation, IR, forensics, anything like that. Those would be stored on the file system, and you can look at those individually through, if you have just a command line tool like TCP dump or T-sharp, you can look at those in the command line, or if you have Wireshark, you can just import the PCAP and look at it like that. So what's also running on this NIC is either Snort and Suricata and Bro on the sniffing interface. So does anyone know what, or has anyone worked with Snort and or Suricata before?
I haven't worked with it, but I know what they are.
Okay, so Snort and Suricata, they're similar in that they are both network intrusion detection systems that work off of signature-based detections. So there's not really, it's not a behavior-based intrusion detection system. That is where Bro, now Zeek, lies. But Suricata and Snort both focus on the signature base. So if we think about this in anti-malware products on a desktop, Windows Defender, by default, and some of your more popular antivirus is going to focus largely on signature-based detections. So if you download a malicious file, like something trojan.exe, it's going, all of those signature-based antiviruses have hash values of malicious files. If you download a malicious file with that hash value, it's going to alert, and depending on the antivirus, it's either going to block it or just throw some kind of warning that there's a malicious file. So this is all based off of AV type detections on the network level, and I'll go into how those work a little bit more when we get in there. Bro, or Zeek now, on the other hand, is actually behavior-based detection. And Bro actually has, or Zeek, I'll interchangeably use this, its own scripting language. It's called BSL, Bro Scripting Language. They may have changed it to Zeek Scripting Language. It's very similar to Perl. The Bro detections and helper scripts and all of the scripting is written in syntax that is very, very similar to Perl. Bro, all of these tools they're just concatenated into the operating system. They are not Security Onion specific. So research that can, if you want to look into Bro more, or Snort or Suricata or anything, that'll go. These are all of they're all individually maintained. Doug just took all of these, put them on one operating system, made them all work together, called it Security Onion. But you can go to any of the pages and I'll show you, and it'll take you in a much deeper dive for any of these products. OSEC, which is now Waza, however you want to pronounce it. This is your host-based HIDS intrusion detection system. So this as well has its own syntax language. It's very powerful. It does a whole bunch of intrusion detections. There's a ton of them already built out. There's a ton more on GitHub, and the same thing for Suricata and Zeek scripts. There's a ton of them on GitHub that don't come by default on Security Onion. It does FIM, which is file integrity monitoring. So basically, if you have a file that should never change, this is good for some database snapshots or any kind of backups where you have a MD5 checksum that should not change. Or anytime you're doing kind of in the CIA triangle, the integrity of data, where you have hash values, OSEC will do the file integrity monitoring to see if that hash ever changes. If it does change, throw an alert. So that's your file integrity monitoring. And then syslog for doing all of the log collection for all of these three here, and then sending them to Logstash. And I'll go over that hierarchy more when we go into the operating system here. But like I said, OSEC is very powerful. So the only one where you actually have to deploy to individual agents or other desktops will be OSEC. Or WASA. So OSEC server runs on Security Onion as well as an OSEC client. So Security Onion actually monitors itself. So you'd have an OSEC server on Security Onion, and then on your laptops, desktops, servers, whatever you want, you install the OSEC client, and that communicates back to Security Onion over port 1514 UDP. But it will gather a ton of different things. As much granular as you want to configure it with system monitor, system utilities, auto runs, processes, DLLs, whatever. And I'll go into more of what kind of use cases Security Onion has built that into. But once all of this data here is curated, it's sending it to the ELK stack. If you haven't has anyone ever used ELK or familiar with it in the industry?
Nope, can't say I have.
So unrelated to just security focused visions, ELK is a very valuable and useful technology stack in the industry. It does not just pertain to security. It pertains to any type of logging that you want to do. So this is error logging, this is authentication logging, knock monitoring logging, any kind of logging you can think, this is what it's built for. So at the bottom we have Logstash. This is where all the logs are initially sent to and parsed. Elasticsearch is where those logs from Logstash, and you can see kind of the arrow going up here, are ingested and indexed. And Kibana is the user interface where you can query the data in Elasticsearch and visualize it in a web front end. And I'll show you that here in just a few minutes. There are a few other components to Elasticsearch. ElastAlert is kind of a time series based alerting system for Elasticsearch, and Curator. We don't want Elasticsearch data stored forever since it does serve as more of a database. Curator manages the indices on that, kind of like you would on a Postgres or a MySQL database, and then trims that based off of an increment that you'll get it, and you'll see what I mean when I run through this setup here. I know this is really all high level right now. It'll probably make more sense when I go through it. But what a lot of people do on here is they will have data from their Security Onion server output alerts or logs into their SIM or whatever kind of monitoring backend that they're using. So they can have alerts go directly to Slack, this little server. They can have it go to your VictorOps. They can have it emailed to you. They can have it go in Jira. A number of different places, or this can all go into a SIM. So if you have a gray log, it can go into here, or Demisto, or what have you, and then do further correlation. The really cool thing about Logstash on Security Onion is you can also ingest a lot of different other file types. So if you have a Security Onion device on a network, and let's say you also have like a Graylog server or some other logging server, you can also send those logs to Security Onion, and they will all be parsed by Logstash and viewable and indexed by Elasticsearch and Kibana. Just to give you a little more context around Logstash and how powerful it is. Anything you can do with Logstash, independently, you can do on Security Onion. So for Logstash inputs, which is maintained by Elastic, you can import a whole bunch of different types of logs or plugins. to Logstash, including events from Azure, AWS CloudWatch. You can actually import stuff from Elasticsearch if you're not running Logstash directly into that. File streams, Gelf, which I was saying was a Graylog format. But also if you have GitHub, GCP type stuff, I'll let you read through this, but there's a lot. And that also includes if you have Palo Alto logs, anything that's working off of syslog, which is most of your firewalls and your switches. All of those alerts can also be ingested into Logstash, and you can view that through Security Onion as well. So it's also a logging tool within itself, Security Onion, and you can view all those in Kibana. And then I'll show you that here when we go through the operating system. So I want to make sure everyone. So for mine, I have a Security Onion server running right now. So there are a few differences when you initially install Security Onion versus another Linux distribution. So as far as installing it on disk, it's all similar. It'll ask you for enter a username, enter a password, and do you want to install it on this file system? Yes, and then it's all set up. I would recommend, so since Security Onion does write PCAPs to disk, depending how busy your network is, that can take up either a small amount or a large amount of disk space.
Anthony, you got the gray box again. I don't know.
I'm gonna pull that up.
Okay, got it.
That can take a small or large amount of disk space. So for mine at home, I only have, it's just me and my girlfriend living here. So I have a 200 gig RAID set up, and that would last for, I could probably store months worth of PCAPs on the file system. But for much busier networks, that may only suffice for a few days. So keep that in mind for how much storage you want to put on there. Security Onion can also work in a distributed system, meaning you can have multiple Security Onion servers on your network. Some can serve as just sniffers, just running Snort and Suricata and Bro, and others can serve as just logging, like just running your elk stack and viewing those. So, to put everything on one server, if you have a very busy network, and then can add a lot of load on the system, especially if you're doing heavy queries in Kibana. And I'll show you that later. That can add a lot of load to the machine, which can then turn, on Snort and Suricata and Bro, they can miss alerts or miss PCAPs for NetSniff. You want to keep the load, as low as possible so that you're not overburdening the system. But that's kind of more an advanced setup, but I'll go into that. So let me see if I can show this.
Anthony, are you set to just share your screen, your web browser, or are you set to share your entire screen?
And I think initially it was set to share my web browser, but I should have just done the whole screen here.
Yeah.
Show your whole screen, it'll probably show up completely.
Yeah. Just realize that if you have any, like shortcuts on your desktop, we're gonna see it.
Oh, that's fine. Yeah, that's big. I need to shop. Sharing here. Okay, I'm going to stop sharing for a second and then reshare on my. So share content, Brandon, is the best way?
Yep.
Okay.
Share content, and you can choose screen or whatever. Yep.
Okay, there we go. All right, so can everyone see my taskbar?
Yep.
Okay, awesome. So since I'm on Windows, I'm just going to use PuTTY. So like I said, I have Security Onion running on my local network. And I'll take you through
Everything looks good.
Awesome. Of what would be the additional setups on a local server. So before I jump onto the server, does anyone have any questions about architecture or anything I went through before? I know there's a lot of material to kind of shove into a small amount of time, but we'll have a lot of time afterwards to go back into anything.
I think we're good to see.
Yes.
So I'll go ahead and SSH into the server, and these are not best practices for SSH. This is just for this lab. Obviously, you're going to do key-based authentication and things like that, but just for demonstration purposes. So like I said, it's running on a normal Ubuntu or a fork of Ubuntu. So you're gonna have your typical, command line, everything you can do in Ubuntu, package manager, you'll be able through here. So on the desktop, as soon as you actually install the operating system, there will be an icon on the desktop that looks like an onion. It'll be called setup. So basically, this will walk through what configurations you want to pass it to do. So I'll show you the example here. So when you run the actual setup after you install the operating system, welcome to Security Onion. Would you like to follow the system services? Yes. If you didn't want to do that, then there's no reason to install Security Onion. This is through X, so take a little bit for the windows to come up here. So initially, it will ask you, and you will need to do this up front to configure your Etsy network interfaces. And what this does, I'll go ahead and just select this. So initially, what we have here is on my server, I have 4 NICs. And what did I set it up with? I have the first NIC as my management NIC. So this is the NIC that's receiving the actual IP address. It's plugged into the switch. It's going to receive DHCP, DNS. It's got the bilateral traffic. I have 1 sniffing port set up because I just have 1 switch. I don't need to span multiple switches on this. But if I wanted to, I could use up to 3 different sniffers. For mine, I just used Eno2, which is plugged directly into the mirror port on my switch. So this switch here, or this NIC here, is set to promiscuous mode, which if you use Wireshark or anything like that, that's what you put your NIC adapters into to just listen for any kind of traffic. When you go through this, it'll ask if you want to put your management interface, receive it via DHCP, an IP address, or if you want to put a static IP address. I would always recommend, and the management interface recommends putting a static IP address so you don't, forget what it is, or if the DHCP, for whatever reason, pool floods, then you forget what it is. It's always set to a static reservation. So that's the management interface I have here. I won't go through it because it'll ask for a reboot. But after you configure the NIC settings, it'll prompt for a reboot, and you'll run the setup configuration one more time on the desktop. But this time, since you already have your interfaces set up, we can skip network configuration and continue on with our setup. So for users, I just want to take a really quick look at evaluating the product. Not intended for production deployment. It's very low spec. Actually, as a general note, I would not recommend running Security Onion on any kind of virtualization platform. Doug also recommends not doing this. It's really meant to be ran bare metal. It takes a lot of specs, and sometimes those specs can be variable depending on network traffic. And then you also have to do, if you're mirroring a port, you have to do additional overhead in the virtualization manager to connect your virtual NICs to the physical mirror port. So best practices are going to be to run this, on a standalone server. But for evaluation mode, if you do want to evaluate it just to see what's going on in the operating system, you can put this into your VirtualBox or VMware or whatever you're running for your virtualization manager and just check it out. If you're intending on running this and you want to see network traffic and all that type of stuff, store logs locally and all that stuff, we would just go ahead and check production mode. It won't hurt if you select production mode and import it into your VM. Just don't use that for a long-term usage. Don't rely on that as what you're going to use. Just use that for checking it out and things like that. So best practices is it should be to deploy this on a dedicated bare metal machine. So once you select production mode, this is what I was talking about, where you can have a distributed Security Onion setup. And if you have an existing one, or if you have existing servers already out there, security onion servers, then you can just add it to existing one. But for this example, we're just going to add it as it's a new appliance. We don't have any other security onion servers running on the network. So this will be the name. It's usually best practice to just use whatever name you use for when you're creating, like, Ubuntu would ask for a username and a password. Just use the same thing here. It's going to store it in regular PAM authentication. So this will create an actual user on the file system. And then usually just the same password as when you originally made when you're installing the operating system. Okay, so for some of these, I would recommend, you guys are all IT and security focused. If you just want to get it up and running, best practices is fine. But for like a teaching scenario, I want to show you guys what it's actually doing behind the scenes instead of just having everything stood up for us automatically. Okay, so as I said, Squeal is a tool, and you access it through a browser that shows the network alerts and things like that. Like I said, Doug is kind of going away from Squeal and Squirt and focusing more on just Elk and for investigation, things like that. The default's 30 days. It's fine to just leave that as 30 days. You can tune that, however you want. If you're not even using Squeal, you can set it to 0 days to not be able to take up, anything. Same with MySQL. MySQL is the backend for Squeal. If you don't plan on using it, you can just set it to 0. So this is where Glenn's joining us. Okay. So this goes back to Security Onion running either Snort or Suricata for the network-based intrusion detection system. So a few differences between Snort and Suricata. Suricata is much more feature-rich. Snort is usually more like beginner-friendly type stuff. It uses a little bit different rule set that you can see here. And it will go through that in the later stages. But Suricata is one of the main advantages of it is it's multi-threaded. So Snort can only run, for example, if you have a 4-core CPU that's hyper-threaded, so you essentially have 8 threads. Snort will only run 4 threads of itself, whereas Suricata would run 8. So you'll get much better application performance out of Suricata. There's certain things where you can look at Snort versus Suricata on the web. I always recommend running Suricata over Snort, especially when you get familiar with it. You can run a lot more. The scripts that you can run in it are, like I said before, it's more of the antivirus based on how it's detecting things. But you can actually write Lua scripts for more like layer 7 type of detections on it and things like that. So it can get a little bit into behavior based, but that's not really where it's focused on. It's focused on the signature based detection. Bro and Zeek is where we get into the behavior based. So if you don't have a pro account on anything, emerging threats open is just fine, and I'll go into what emerging threats is here. So emerging threats. So basically, how does Suricata get its rule set? It is something called emerging threats, and this database is actually fully maintained by Talos, Cisco Talos. So out of the box, you'll have around 40 to 50,000 rules. And by default, these rules are all grouped into different categories. So you will have things that are protecting your bot command and control, D-Shield, which is something that serves out malicious IP addresses. You have compromised IPs. So ActiveX, adware, attack response, chat, and I'll share this link in the channel as well after we're done here. But it looks for a variety of things: exploit kits, ICMP stuff, malware rules, mobile malware, all this stuff. So it has all these different categories. And then I'll show you how it contains an individual rule file. So without going too deep into it at this time, I will show you kind of how a default rule would look in a Suricata file. So by default, every single rule is assigned a unique security identifier, aka a SID. This will always be unique to every single Suricata rule. So of the tens of thousands of different rules that are in there, each one will have a unique security identifier, and that's how you can identify that rule particularly. So as I said, Suricata has its own homepage. You can look into how to write your Suricata rules, how the formatting works, how it's parsed, what all these things mean. But at a very high level, we can do different traffic flows. Everything is alert based. So this is, for example, if you want to look at a exe downloaded compressed file. By default, we're looking at TCP streams. You can identify this as UDP, HTTP, DNS, a multiple of different protocols. Just one thing to note is this is always network port, network port. So in this case, since we're looking for a download, external net being not your home net, I'll go into that what that is. Any port on your home net, any port. Flow is established, content MZ. If you don't know what how Linux differentiates files from Windows, Linux uses something called magic bytes. It doesn't rely on the file extension like Windows does. So in Windows, if you rename something to .docx, it will automatically assume that word is what is going to open that. If you do that in Linux, that doesn't matter. It goes off of the magic bytes that are written in the actual file. So MZ are the magic bytes for exe in Linux. This will have some references in it, as well as revisions. This is the 9th time this rule has been revised. When it was initially created, when it was last updated. I won't go too much into what other things are. Suricata works off of a 1, 2, 3 or high, medium, low alert. So unless you define specifically, and most are not, unless you define a field called severity, 1 is low, 2 is medium, and 3 is high, it goes off of the class type. And I'll show you on Security Onion where you can either edit, but how it is out of the box is pretty much anything that's classified as definitely malicious, like a Trojan or malware or a command and control server. Anything like that will be considered a high alert. Medium alert would be miscellaneous activity. We're not exactly sure what's going on, so it's just classifying as miscellaneous. It may or may not be malicious. Or if it's just like informational or something like that, it will be a low. But you can see all that on Suricata, how it default ranks that. And then I'll show you on the actual file system how you can change those. So with our NIDs, I'll select Suricata. Any questions on all that Suricata stuff? I know that was a lot to throw at you at once, but just want to make sure we cover as much as we can.
No, that's great. Doing great.
Awesome. So we do want to enable our network sensor services, including Snorter Suricata, Zeek, and NetSniff. You can set up Security Onion to just be an OSEC server or a WSOS server, and then you'd have OSEC clients, in which case you would not need to run network sensor services. That's kind of what it's asking you right here. But in this case, we are going to be sniffing traffic. So we do want to make sure that those are enabled. I'm not going to go into too much of what some of this stuff is. It gets pretty complex with NIC configurations. Essentially what this is asking though is if you have a very busy network, the number should be closer to this, which is your highest port value. The default is 4096. I don't have a very busy network. This variable doesn't matter too much. and it can be changed. All of these variables can be changed after we run through setup. So if you do a misconfiguration accidentally, it's fine. But my network, my home network, has very little traffic, so I'll leave it on 4096. This is essentially what's putting it as a ring buffer. I'll go into that on a later setup process. So since I already went through the configuring Etsy network interfaces, your default sniffing interface that you configured there will be automatically checked. What this is doing is saying, if you forgot something in there, do you have any additional NICs that you would like to configure as monitor interfaces? So do you want to select 3 and 4? In that case, I'm not monitoring anything, so I don't have those selected. A very important note to consider on this is if you in this case specifically, I could go ahead and just say, yeah, I'll check these because I only have one management port, so I'll just set the rest to sniffing. Definitely don't do that. So what happens on your sniffing port is, regardless if it's receiving traffic or not, Suricata or Snort, NetSniff, which is gathering your PCAPs, and Bro or Zeek will run threads on that interface, whether it's sniffing traffic or not. So I know for me, I have Eno2 plugged into my mirror port on my switch or my span port. I don't have these plugged in. So if I actually enabled these, even though I'm not receiving traffic, NetSniff, Bro, and Suricata threads are still going to be running on that, which is going to take up a lot more system utilization than just running it on one thread. So if you're not sniffing on those interfaces, leave those unchecked. You can always go back and add sniffing interfaces. So in this case, we want to make sure we're allocating exactly what we need to and nothing more. Like I said, in all of this setup process, we can always go back and modify the variables. So for what we're setting up, make sure it's just setting up for exactly what your use case is right now, and you can always scale up. Any questions about that? Because that's an important part. Awesome. Sometimes people may just want to run Bro for just behavior-based alerts. They don't want to deal with any term is absent from me now. Signature-based alerts. In that case, they wouldn't run them, but we do in this case. We want to run all of our network sensor services. So based off of the inputs or the values that you inputted on past setup screens, and based on your CPU cores, the setup process will recommend how many threads of Suricata and Bro you want to run on each interface. This can also be changed afterwards. And for example, if you need to change this later, it can be changed in this this path here. So I'll just go off of the default 7. I'm running this on a server with 2 Intel Xeon cores, so there's 16 threads total. But this is where it would come into play, where if you had those additional NICs and they weren't sniffing traffic, they were just sitting there, now you would be running 21 processes, since we have, you would have 3 interfaces, so that would be dangerous to a system utility usage. So this is where I was talking about your home net variable. So traditionally, your home net is always going to be set to your private CIDR. So your RFC 1918 addresses. I just leave mine because I have machines in all of these different subnets. But if you're at home, or if you have it set up different on your router, where maybe you only have your Class B network, your 192.168, or your Class A 10.00, or your Class C 172.16. You can further drill down and maybe just say, I only want to, make my home network just 172.16 and forget about the first 2, because I don't have anything running on those. So there should never be a DHCP allegation to any of that, and that's potentially a rogue DHCP server. But for me, I have all of them running, so I'm just going to leave that as my home net variable, and I'll show you why that's important after we run through this setup. We would like to enable Zeek, formerly known as Bro. So Zeek also does file extraction, which is pretty cool. EXEs, like it says by default. Of course, it's not going to catch any of those files in an encrypted stream. But if you're downloading things like PuTTY or things like anything over a non-encrypted stream, it will actually extract the file and store them in NSM Zeek extracted, so that later you can do other analysis if you want to do like static file analysis, dynamic and file analysis to see if you downloaded a potentially malicious file. You can see those on the actual file system, and you can even export those to like a sandbox or something like that to do further analysis. So I do enable file extraction. Zeek is going to do the same thing. So how many Zeek processes do you want to run per interface? This can be changed in this file path after if you need to change it. I'll just do the default 7. This is where some people do enable full packet capture. Some people don't. That's really dependent on your use case for it. If you're not going to be doing any forensics work or IR or things like that, or if you don't have the disk space, and you'd be able to on a busy network, you're not able to allocate a lot of disk, and it's you're only going to be able to store the last 5 or 10 minutes of PCAPs. It may not be worth it. Or if you don't have the system utilization like the additional RAM or memory or disk, then some people just wouldn't store full packet captures on disk. But for mine, I always like to do it. I have the extra space. I have the resources to do it for RAM and CPU. So by default, NetSniff will store PCAPs 150 megs in size and then rotate. So I'll show you how they're stored on disk. You can change this variable to however you would like it. On slower networks, you can change it to maybe every 10 megabytes because there's not a lot of traffic. So you're not going to have a lot of PCAPs. And it might take a long time to actually fill an entire 150 megabyte PCAP. And then on bigger networks, you could even expand it to say, I want to go to a gig, because that gig might fill up relatively quickly. It doesn't give you the option to here. You'd have to go into the binary, and I can show you how to do that. But you can also rotate PCAPs based off of time. So you could tell NetSniff to rotate a PCAP every 5 minutes. So no matter what size it is, we just want to rotate it every 5 minutes or 15 minutes or 20 minutes, whatever that variable. So even though the security onion setup only gives you the option to do it based off of size, we can also do this off of time in the file. If we have enough time, I'll show you how to do that, but I'll just leave this at the default. This is something that still Doug has been working on. I don't usually enable this. For a higher performance, if you're on a very busy network, by all means go ahead. If you have DDR4 RAM at least 2400, that's fine. Since I have a server, it's running DDR3 at 1333 and 1600 megahertz. So I just use the default gather method for NetSniff. You can go in and see what the differences are from my home network. It's not going to make a difference, so I just use the default. So a PCAP ring buffer, basically this is setting aside RAM for your NIC, so that if you have a large inflection of traffic that comes through, you have memory available that can process that, rather than just basically DOSing your promiscuous mode NIC. The default 64, it'll tell you if you have a much busier network and you have more PCAPs flowing through there, more data coming through your sniffing interface, you can increase that. The default 64, I always just set mine at minimum 256 is fine. This is how often it's going to begin purging and cycling old logs. You can change this to, I don't recommend going over 90% on any file system. I usually just leave it on 88 because usually when I'm doing knock monitoring, I'll monitor for when the threshold reaches 90%. So I don't want it alerting me every time it reaches 90% and then it just rolling over. So I usually set it at 88 or something like that. And then have a rollover and I won't have to worry about alerts. But this is fully what you want to do it. I would definitely never recommend going over 90. That's when your read and write speeds start slowing down a little bit. I'm running this on SAS drives and a RAID configuration. Obviously, for optimal performance, you would have SSDs in there. Enterprise SSDs and servers are pretty expensive, and I'm not going to drop that kind of dough if I don't need to. Does anyone know, or has anyone ever worked with a technology called SaltStack?
I have.
Yes, Brandon, we use it at work. So Salt is in the realm of other technologies such as Ansible, Puppet, and Chef. It's for remote management, remote configuration without having to touch the server. It's basically a command and control setup. For Salt specifically, it's a very easy architecture. You have a Salt master and a Salt minion. The minion is always calling out to the master. So the cool thing about Salt is, let's say you have, let's say for Doug Burt's especially, if he's managing multiple clients' setups, he may have 50 different security onion servers that he needs to help manage for clients. Well, if he needs to deploy a change, the same change even to all of those servers, it's going to take forever for him to SSH into each individual server, especially if the client isn't familiar with Security Onion and they're not comfortable logging into the server locally and running something. That's going to be very time consuming for someone like Doug or anybody who's engineering or managing the servers on their end. So what Salt does is basically you can have any amount of minions all call into the Salt master. So from the Salt master, I can tell all of my minions at once, hey, do an apt update. And it will issue that command to all of my minions at once. Don't need to worry about doing it individually or SSHing into that. So it's a very streamlined and optimized way of managing a bunch of different resources. And the really cool thing about Salt, as opposed to Ansible, Pup, and Chef, is that Salt works all on egress traffic. So let's say, for example, at the firewall, if I'm sitting outside of my network, and unless I have a VPN set up, I would have to do like an SSH port forward into my server, which is always poor security practice. So the cool thing about Salt is it's all on egress traffic. So the Salt minion is always calling out to the Salt master, every few seconds to just keep the TCP stream alive. So I don't have to actually open any in-ground or ingress ports. I don't have to allow whoever's managing the sensor on a WAN to remote into through the firewall and then connect like that. Salt minion is just going to call out over ports TCP 4505 and 4506 to the Salt master. So I never have to worry about opening any inbound ports. So that's always a big plus for security if you don't have to do that. And if you have any more, side questions on Salt, I'm always, happy to answer that. For mine, I'm not managing mine with Salt. I have one. It's on my local network. I don't have to worry about managing it remotely. I'm not managing it remotely, so I don't run Salt on it. This is where the Elasticstack is. Like I said, Squirt and Squeal used to be like the tools a while ago, and then Doug brought in ElkStack, and now this is like the thing to go to for storing and analyzing and visualizing logs. So definitely want to enable our Elasticstack. So this is where I was getting into where you can have a distributed security onion distribution. You can have multiple security onion servers in your network. Some will be just for storing logs that you can, if you're querying. Some will be just for sniffing network traffic. This is to distribute load across your sensor fleet. So like I said, when you're in Kibana and you're querying data, that can put a large overhead, especially if you're doing large queries that would be over a large time frame. Like if you're querying all data for the last year, it's a very large query, and that can crash your server if you're running it all in once, or just take a long time and eventually time out. So for load balancing that, some servers would be specifically used for storage and querying logs. Some servers would be just for sniffing that traffic. So for ours, everything is just local. I'm not worried about load balancing. I have very minimal traffic, and the server is well spec'd for my use case. This will ask you, and this will base it off of your disk size, how much disk space you want to allocate for Elasticsearch logs to store. I would recommend doing as much as possible, because then you can always go back and get over that amount on Elasticsearch. So whatever the default is, just make sure it's less than 90% of your disk space in here. I have like 386 gigs. I'll check on the file system, but that's perfectly sufficient for what I would need. And like I said, all of these variables you can change after the fact. So it'll give you just kind of a rundown of what it went through here. It's going to create a user. It's going to follow. It's going to monitor this NIC. It's going to run 7 load balanced processes for interface for Suricata, 7 for Zeek. Download the emerging threats rule set. This is your home net. We're going to configure Elasticsearch. I've already done this, so I'm not going to remake those changes. But here you would just click yes, proceed with changes. It takes a few minutes to just do those changes. Once it's done, you're good to go. So for mine, it's going to X out. So now we have everything going on the file system. All of our ELK services are up, everything like that. Has anybody ever worked with any kind of containerization technology, like Docker or Linux containers?
I played with Docker some.
Okay, so Doug actually containerized through Docker. I don't know why first password keeps failing. Some of the services, including ELK. So, for example, all of these services, and I'll go over what they are running inside of containers. They're not actually apt installed on the file system. I'm not going to go too much into containerization right here because that's a whole other beast on itself. But basically, these are not running, the services themselves are not running on the file system. They are mapped to storage on the file system. But it's for much easier upgrades or rollbacks or anything like that. It takes up less system resources. It's kind of a win-win to just run it in containers if you can. But by default, these are already ran there. So we already said what Elasticsearch is, Kibana, and Logstash. That whole stack is running in different containers. ElastAlert, that's just your time series. Concatenation, I'll show you what that is in Curator. Just make sure that Elastic indices are rolling over when they should be and are maintained as they should be. So all of this stuff is running in your as a container, and all of these are up as the Docker command shows. Everything else like Suricata and things like that are running on the actual file system. So to start, SecurityAgenda has a ton of different commands built in. I'll show you what they are, but one of the most default ones is just SO status. So sudo, SO for security onion status. This just makes sure that everything is running as intended. These two things I set up last night. I didn't set them up as I should, but don't need to worry about them. As long as everything is okay, which we get here. These are all of your, your Squeal server, your OSEC agent. These are all of your Zeek workers. NetSniff, your PCAP agent, which is NetSniff. So Snort agent for Squeal. We're not using Squeal, but it'll still run it automatically since we're running an IDS. And the rest of these are Dockerized. So I'll go over my system specs real quick. So like I said, I'm running this on a server, so it's really not taking up any of my CPU. It's really not taking up any of my memory. So I'm fine on specs, on the uptime. As far as disk usage, you can see I have 333 on my RAID SDA1. I'm only in 3% usage right now. PCAPs are what are going to take up the most storage on your file system, but like I said, it's me and one other person, my girlfriend, live in my house. We have a few IoT devices like smart TVs and things like that, cell phones, but we're not doing anything that will generate large amounts of traffic for a long amounts of time. Maybe stuff we're just testing, but it's never usually persistent. So I'll show you without further ado. One thing on checking your network interfaces. So with ifconfig, these are all VE is all Docker nets. I won't go into detail, what that really are. They're just Docker nets. You don't need to worry about them. So what we have when we're on ifconfig, so like I said, my Eno1 interface is my management interface. It has an IP address 0020. Eno2 is my sniffing interface, and you can always tell which one you set up for sniffing interface when running ifconfig because it will set up this broadcast running no ARP promiscuous. Notice how Eno3 and Eno4 do not have that no ARP promiscuous mode. So now I know that this is the one that is in promiscuous mode. And to make sure that we are receiving traffic, other than just looking in the interface and realizing there's no traffic there, TCP dump comes installed on Security Union. So it's always good to just do a quick test after you set it up and do a TCP dump on the interface that you're sniffing on, just to make sure that you're receiving traffic. So TAC I is the interface flag for TCP dump. And I'm just going to set that on Eno2. And I need to run a sudo. And there's very, very little traffic going through my network right now. Not much happening. But now I at least know that I'm receiving traffic. If I was to run this on another interface, which I know is not sniffing, like 3, it will just sit there. Nothing's happening. Nothing's coming through that interface. Nothing's going to show up. So that's a good way to tell that you are receiving traffic on your sniffing interface. Just run TCP dump TAC I and then whatever the sniffing interface is. By default, when you configure, when you're done with the SO setup, it will configure UFW for you. So for mine, I just disabled it, but by default, it will configure only SSH to be allowed. So we'll have UFW rules and they're just only allowing SSH. To view Kibana and all that stuff, you have to also open port 443. And then if you're doing other stuff like OSEC, you need to open additional ports. It'll tell you, what to do that in the documentation. But for these purposes, I just disabled it so we can make sure we're available in services here. So if I browse to the server IP over HTTPS, it'll just give you a self-signed cert warning. And we land here at the Security Union page. Doug has really done a good job of maintaining and updating this page. This used to just be all in clear text and take you straight to Kibana. Now it has a full cheat sheet and all this other stuff on it. So this is a full cheat sheet on what specific commands to do if you need to restart services, check status, if you need to update Security Union. So rather than just doing regular apt update and apt upgrade, SOUP, standing for Security Onion Upgrader, running that, just sudo soup will pull down all of the packages that apt would pull down and the ones that are associated with Security Onion packages. So you just run sudo soup. You can do that as a cron. If a reboot needs to be initialized, you just have to do that. Updating, so like I said, ET rules, they are pushed out, new ones are pushed out and or modified, usually every single day, Monday through Friday. So it's always good to set up a cron job to just have a rule update run once a day. You can do it at 2 a.m. or really whenever, it doesn't matter, to pull down the latest rule set or any modifications or anything like that. SOSAT is the one that I ran that would generate SO statistics, check service statuses. This is all here on the default page. It tells you what important files. This is where if you want to modify files or see where configurations are, these are where they are located in the file system. For packet filtering, configuration files, data directories, log files, performance tuning, it's all there. So right in your interface, you can immediately start tuning it. CyberChef, as I was saying before, kind of your Swiss Army knife. This is running on the local server as well, but you can search things, convert a bunch of things to regex to hex and all this different encoding, different hashing algorithms, compression types, networking, public key type of stuff, but really useful for just networking stuff and forensics and things like that. So I'll let you guys play with that. It's not something that is usually very specific to Security Union. This is a tool you can download anywhere. Since Squirt and Squeal are kind of they're not officially deprecated, but we don't really use them to view the alerts. Everything is in the Oak Stack and Kibana now. That's where we want to go. So this is going to be the same username and password that you created during SO setup. So before I go into elk and cabana, any questions on what we've covered so far?
This is exactly, I think, what I was looking for. Thank you.
Awesome. Okay, so this is how, from an analyst standpoint, we would be viewing everything. So you're generally not, unless you're part of like engineering or development team, going to ever be really SSHing onto the file system to do any kind of, not like everyday analysis. This is where you will be doing it from. You'll be logging in remotely. You can plug into the actual server that Security Onion is running with like a VGA or HDMI port. It'll come up with like a Security Onion background, but kind of like an Ubuntu GNOME desktop. I think it's actually XFCE, and do it off of that. But that's not, really best use case. Just access it over the web, which you would need to. And this is what's going to pull up your Kibana dashboard. So there's a lot of stuff here. Don't be overwhelmed by it. It's pretty simple. There's a ton of documentation surrounding this stuff and what it is. So by default, you'll land on the home page. Total number of logs. This has only been running since Brandon, you and I set this up in my home lab yesterday around like 4:30. Hasn't even been running for a full 24 hours, and I have very little traffic on my network, so there's not going to be a lot of logs. So basically, the first things I can see when I come in here are my alert data. So do I have any Zeek notices? Probably not. HIDS alerts are going to be your OSEC and Waza. And like I said, Security Onion monitors itself with OSEC. So there are OSEC alerts on here, nothing to be like concerned about, but it does say there was a login session open for my, SSH. I changed my UID when I went to root. Integrity checksum changed on a file. A new file was installed via dpkg. File added to the system. There's a whole bunch of logs. And this is all it gives you the username, and I'll do a deep dive into what these are ran. These are all the commands that I've actually ran as my user so far since I've had this up. So it does display a wealth of info just off of these default dashboards. NIDS is going to be your Suricata or Bro alerts. Probably won't have any because my home firewall filters out all the bad traffic on the IPS type of mode. But this is where you would see it if it was there. Zeek hunting. So Zeek is also a very powerful log collector and aggregator. So all of these things under Zeek hunting are different type of Bro or Zeek logs. So you will actually have a bro.dhcp log, bro DNP, bro DNS, bro files log, bro FTP. It is able to parse files as they come through the wire into what they are based off of protocols. So if I want to see, radius traffic, RDP traffic, SIP traffic, SMB, these are all built in by default. I don't have many. Obviously, I just have DNS, DHCP, and TP log. But you can drill down into, for example, a DNS log, and this will show you, what was, your PTR records, your A records, quad A records, the clients that made the queries, the servers that they queried against. 10.0.0.1 is my home gateway. It has it will match any DNS attempts against the top Alexa phishing sites. I don't have any right now, which is great. Here are my actual queries. So I have servers running on my local system, like I said. Service 1 is my local laptop. Running logstash and nextdiff locally. So you can dig in and see what queries, and I'll show you what that looks like in the query field, but not a whole lot here to be expected. And these are the answers that are returned for the DNS request. So not too much going on. I have a slow network, kind of anticlimactic, but so for OSEC, this is what dashboard, if you want to do a specific hunting with OSEC, if you want to dig into alerts more on here. OSEC has a little bit different of a scoring system based off of severity than, like I said, with Suricata, which just uses high, medium, and low, 1, 2, and 3. OSEC uses 0 through 15, 0 meaning least severity, and 15 meaning something just like blew up, you need to look at this immediately. these are all the different logs and how they're located. I'll go into OSEC more on this. You can look at auto runs, and I'm not monitoring. I don't have any OSEC clients on any of my other laptops at home. This is just what's on the server here. And the really cool thing about OSEC is it's not just a security tool. It can monitor actual system processes. So this is actually monitoring your Apache logs, since this is Kibana's running on Apache 2. So I access Kibana, so that's what this is. It's monitoring your listening ports. It's monitoring your packets received. So if all of a sudden I just stop receiving packets, OSEC would report that there have been no packets received in the last whatever 30 minutes or 20 minutes or whatever you can set that variable to. So it does also monitor a lot of system changes. And note that in Kibana, this is set to auto refresh, but this is the data, everything in here set for the last 24 hours. You can do a quick time range of any of these variables. So year to date, last 90 days, 60, 30. Just keep in mind, the longer time range you go, the more data you're querying and the more load that you're putting on the system. With me, I'm not worried about it because my server is severely overspec'd for what my home network is. So, but normally, you're not going to dish out. You're going to be more conscious of price in a enterprise environment, and just learn to filter off of the time range that you would want to do that. You can all just do this, 22 hours ago or 22.5 hours ago, or if you want to do an absolute time range based off of like this specific data, this specific up to the millisecond, or just any recent searches that you've had in your history, which I don't have in my history right now. Kibana also has a really cool documentation page off of how to use it. All of this is maintained by elastic.co. They maintain Logstash, Kibana, and Elasticsearch. So they have their full guides on all of them. They're also all open source. They have a bunch of different plugins for Security Onion on GitHub. So that's going to be your default dashboard. You can see some other random stuff like stats. When you're querying Logstash, the average time it takes to return a query. I haven't been monitoring it at all, really. So I haven't been querying it, really at all. So it's not really going to show up here. So the thing that is the best thing that Doug has added, none of these, there used to be no visualizations by default. You had to actually add them. Doug has included now 395 dashboards or visualizations, and there's a ton more on GitHub that you can import. But there are a ton of different things that you can look for that are automatically built. So if you want to look at, there's things for auto runs, there's things for NIDs. All of these things are default dashboards. I'll show you kind of a default one. So if I just want to look at connections for, let's go with like protocols and a bar chart. This graph is built. So I have mainly UDP traffic. There's some ICP and some UDP. The large amount of UDP, everything over like your real-time streaming protocol is going to be UDP for streaming devices, which is the majority of our traffic in my house with smart TVs. So that's going to be the majority of the traffic here. But just realizing there's a ton of different things you can do, or just like whatever kind of search you want. This takes in regex as well. So NIDs, alert count, alert summary, alerts over time, alerts based off of destination port, based off of IP address. Just a wealth of different logs. Same thing with OSEC, by agents, by classification, just a ton of different log counts and stuff. And you can go into all these and play with them at your leisure. The Discover tab is really where we're concentrating in Kibana. It's where we can do all of our custom queries. This is by default KQL, Kibana query language. It's very similar to just like a MySQL kind of thing. It's very top level oriented, very easy to operate around. It used to have a little page to go to for more resources, but I don't see that. So like I said, Bro maintains a lot of different log types, and one of probably the most important one is called BroCon, standing for your connection logs. And the BroCon logs are as close as you will get to a PCAP without being a PCAP as you will get. So for example, And you'll learn these queries the more that you work with Kibana. So I'm just going to do event type is bro_con. This will show me all of the bro con logs in the last 24 hours and kind of how those logs have built up over time. But for example, this is an example of a table. You can see it in a JSON as well, but a table is a little bit easier to view. It'll give you, the timestamp, the destination IP. In this case, it's just the gateway. It'll give you the IP addresses involved. It'll kind of give you the whole message associated with it, MAC addresses, the size of it, of the packet in bytes, the return of the packet in bytes. This is just a broadcast message. Nothing is returned. But obviously, this is a very data-intensive log source just on its own. And then I can further query off of that based on anything. So like I said, BroCon was one. If we want to look at just DNS logs, Bro DNS is a different type of log. So for example, let me find a good one. So for example, I can look at DNS logs based off of the, in this case, it would be the destination IP of whatever server you're going to. This was stored locally on a server. This is just a query class name would be C name. If it was an A record, you'd see that here. If it was a quad A record, PTR record, and then you would see the actual domain query for. So all of this stuff is available. All of these fields here are indexable, meaning you could also put in, for example, like and query type A record. There may not be any A. Yeah, everything's clashed locally, but I don't know if I made PTR records. Probably not. Yeah. Or if you want to do it based off of, in my case, destination IP, which my firewall also functions as my DNS server. So anything that's querying that, whoops, I have two hands in there. So none needed to query at that time, but everything forwards to, probably won't do that because that's outside the firewall. But yeah, so if I had any Suricata alerts, it would actually be under sort still, but it gives you a whole bunch of default queries by default. Like if you want to sort by alert level, just a ton of different ones by default on the side here. This is where I was searching off of event type. It'll show you the last 10 records. So event type OSEC. Even though it's called Waza now, it's references OSEC still in here. So there's an OSEC log. Fine. We'll just see what's going on this one. There was an access log in the web. That was me accessing from Mozilla, the Kibana web interface. This, like I said, the alert levels go through 0 through 15. This one was just a 3. I successfully authorized with my username and password via post request. This is my laptop's IP that I came from. The location that OSEC pulled this log out of was the access log, which is where Apache stores everything that's accessible. This is the full message that was on there. My security onion server is called SecOnion. And then I accessed, on the local host. And then it also gives you field names, web, AppSec, and attack. The really cool thing about OSEC also is that it matches against, it'll give you tags for PCI, HIPAA, CIS. I'll show you that when we go into the actual OSEC rules. So you can actually benchmark or build OSEC rules to benchmark to those compliance standards. But this in itself is just really just, the more you play with it, you can learn. This also, you can look at logs for the last 24 hours. You can do the last 15 minutes, get a more granular look. Or in the interface, you can actually just drag and drop. So let's just say I want to look at this middle bunch of logs. Kibana will automatically just take that and add it to the date field up here, and then I'm looking at that, specifically. I know I went through that like really fast. Any questions on like Kibana or what I've shown so far? Awesome. I'm going to hop out of Kibana and show you some things on the file system. So by default, up here, most of what everything or where everything is with Security Onion is located in Etsy NSM, and these are all on that page in Kibana where where the cheat sheet is. Basically, all I'm referencing here is where the configuration files are at, and I'll go over some of where the log files are, and the data directories and role management. All the stuff that I'll be showing you on the file system is pointed out in the cheat sheet here. You'll eventually work with it enough to where you'll pretty much know all these by heart. So in Etsy NSM, to modify additional things, the Security Onion configuration file is where you could start modifying some of the things that you set in some of the variables that you set when you were going through the setup process. So here you can change your engine to snort if you wanted to go through that. If you realize, hey, I looked at squeal, I don't like it, I don't need it, you can just change the days to keep to 0. Same with the MySQL, we don't need any of that. When will basically OSEC warn you on disk usage? You can change that to like, maybe I want to be warned at 50%, but don't actually don't start purging data until 90%. So you can change this to however you want. Maybe you don't like Bro, you don't want it. We'll disable it. Don't change the squiggle to groups, that'll mess up permissions. Explico is no longer available. You can change DockerNet. I wouldn't enable or recommend doing any of that. If you don't want elk stack enabled and you realize you like squiggle for some reason, that's fine. You can just change these to a no. We don't want Elasticsearch, we don't want Kibana, that's fine. And some additional options. So for now, we like all those options, so we're going to keep them. Going to so rules directory. So this is where all of our Suricata rules are stored. And like I was saying with classification, all of our different, so these are all of the different classification types, and I'll show you that in the Suricata rule that I had up. So the one that we had up, for example, class type miscellaneous activity. So all the different class types are here. So we can change these so that for that, whatever rule is firing on those for the class types, we can change that to a 1, 2, or 3 for all of those classification types, 1 being low severity and 3 being high severity. So for attempted admin, that's by default a 1. Attempted DOS by default a 2. You can go through these and, maybe for your network, maybe you want to change attempted admin to a 3 or a 2 or whatever. Actually, this is the other way around. 1 is actually the highest and 3 is the lowest. ICMP event, not being very important, but maybe if you felt that like a trace route was very important that you be notified, you would change that to a 1 or, however you want to do that. But by default, your Trojan activity, your web application attacks and things like that will be automatically set to a 1, just because, by default, they're attacks and, Trojans and things like that. So you can adjust that to however you would like. The actual rules that we have in here that are downloaded so far are going to be in the downloaded rules. This is a massive, massive rule file. So this is all of those ET open rules stored on the file system and pulled down. So for example, if you wanted to look at a rule on the file system based off of the SID and you know what the SID is, you can just, for example, this rule, we can just grab it and we can grep based off of that. And now it's just going to show me that rule and what it does. So that's in Etsy NSM rules, downloaded rules will all be on the file system. If I need to update my rules, which I said it's good to implement a cron job to update those daily and get the latest rule sets, I would just implement sudo rule update. This is going to reach out to emerging threats, see what the differences are. Same thing how apt works, reach out to the repositories. It'll give you this little change log here, which these are also stored in a log file. of what was added or appended. There were no new rules. I just ran this yesterday. There were 225 rules that have been deleted. Out of all the rules that I have, there's 29,000 total rules. Only 19,000 are enabled. The other 9,000 are not enabled. They're disabled. They're probably very low fidelity rules. But I'll go into what that would be. And you can always add your own Suricata rules. Either you can build them, or there are a ton of contributors that contribute their own rules on GitHub for Suricata rules for specific APTs, or like just for specific types of ransomware or emotet or anything. So you can easily just go pull those and put them into it's actually called your local.rules file. That's things that you've made or put in there. So for default, there will not be anything in your local.rules. But that's where you would put anything where if you went on GitHub and saw rules, or if you built your own rules, that will never be overwritten. The only thing that's overwritten when you download rules is your downloaded rules. Everything else remains kind of the same. So let's say we want to modify some stuff with Suricata. You would have to go into what you would do is the sniffing tab interface. So it'll give the host name. So for example, like my host name of my server is SecOnion. So it'll just say SecOnion Eno2. And I know that is my sniffing interface. And I know Eno1 is my management interface. So if I want to modify things on my sniffing interface, we'll just go into the directory that will contain that file. So in this, there's a lot of symlinks. I'm really only concerned with the suricata.yaml file. If you're running snort, you would be concerned with the snort.conf. But I'll show you a few things in the suricata.yaml that are worth taking note of. Okay, so by default, like I was saying with the HomeNet, so when Suricata is running those rules, like I said, for the HomeNet variable, an external net variable, this is where it's getting all of these variables for. So like we passed in when we were running through setup, my home net is set to all of these nets. We can append this, like I said, to just a class B, just a class C, just a class A, or if we were only running things in a DHCP scope that were like a /24, we could even do it like that. But for now, I just left it at all the default private CIDRs. One thing that I've actually talked to Doug about, and he's going to implement a fix in, is so the external net is actually set by default this way. It's set to external net being any. So basically what that will do is if you have a rule that's doing, for example, external net to home net, it doesn't matter because your home net is set to any. So it's going to override that variable and just say like home net to home net, and that will spam you with alerts. So what I do is just pound that out and send my external net to the variable not home net. So basically just saying my external net is equal to not 192.168, not 10.0, not 172 addresses. So basically anything that does not have a private CIDR address, the internet, is considered my external network in my case. The same thing with here. You can go through if you have HTTP servers or HTTPS servers on your network. You can put the actual IP addresses here, separated with commas. The same thing with SMTP, DNS, SQL, and then the ports that they are running on. If you have HTTP ports on uncommon ports, you can put 80.443, 80.80, 56.01, whatever you're running those on. SSH ports 22 if you're running those on non-default ports. The rest is kind of outside the scope of what I want to go over, but that's a brief description of the .yaml file there. So that is important for when you're talking about external net to home net. So this, and in our case, would be anything from the internet or non-private CIDR to our home net. Things that are updated more often are actual CIDRs, and these are all public CIDRs. So for example, this rule is saying incoming UDP packet from Amazon EC2. All of these CIDRs via Cisco Talos Intelligence are recognized as EC2 instances, or instances are running in those CIDRs. So basically, we have an incoming UDP packet. In this case, we'll go through it. So anything with the UDP protocol, that's why it's important, or I'm sorry, it's important to specify, what is, if you have HTTP servers SSH, because this is protocol aware. So you could do alert TCP, like it is down here, alert SSH, HTTP, DNS, a bunch of different protocols, and it will only look at that protocol. It's good for fine tuning. But basically, this alert is, if the traffic is originating from any of these CIDRs not on port 53 to our home net, which in our case is our private CIDRs on not port 53, then start looking for stuff in the packet. This by default is a policy category, which by default will have a medium severity. Here's your SID, so you can grep through that. And then I'm sorry, the class type, not the policy, is command and control, which by default is a high severity. So the only way to actually override this for specific rules is by including a severity field. So for example, the variable for that would look like severity 1, and that would be your high level alert. And that just takes in 1, 2, or 3. But that's all on the Suricata homepage on how to just append that. Otherwise, it's just going to take it from the actual class type. Anytime you make changes to anything on the system, you need to restart it. So, for example, if I did make a change to Suricata or anything like that, I would need to restart it. And the commands for that are in that Kibana cheat sheet on how to restart things. There's also one that has a lot more commands on it. But for starting sensor services, there's a few different ways you can do it. Rule update will restart Suricata. But anytime you add rules, like in your local.rules file, or you make changes to the classification, or you modify your suricata.yaml file, you have to restart Suricata for those to take effect. Same thing for Bro. So before I jump into Bro, does anyone have questions on Suricata?
Go ahead.
Sorry, last thing I wanted to show on Suricata. Pulled pork is the rule manager for Suricata and Snort. So pulled,
Exactly what I looked at it and went, what is that?
right. So pulled pork, and there's a few different ones. Pulled pork is probably the best one. So pulled pork, if you're on Snort, they kind of have like the whole pig motto with like pork and stuff, whatever. There are different rule sets. ET Pro is the biggest and widely maintained one by Talos. There's an actual ET Open. ET Pro rule set is a paid rule set that Proofpoint manages. So that is all of the ET Open rules with rules that Proofpoint specifically puts in there. And I think there's an extra like 10,000 rules that you would get. You also get rules to access earlier than ET Open would in the Open. We've ran that. It's like a hit or a miss, depending on what your use case is. It may be useful. I think it's a couple $100 a year. The last time I looked at it, but basically, pulled pork is the rule manager. So there's just a few things in here that I'll go over. One of them is the pulledpork.conf. The URL that it's pulling from is your, and I browsed through this. This is what I was looking at the Suricata rules in. But this is the URL right here that it's pulling from. If you actually had an ET Pro format, it would be ET Pro blah blah blah. ET Pro or Proofpoint will give you an OINC code, which is just a string of variables. You would put that here, and then unhash that, and it would use that rule set. This just points to different file paths and things. You don't have to change anything in here by default. Everything's set up. A few things to note are anything that you put in disable SID, which there are two things in there by default. Anything that you put in here will be disabled. So you can put individual SIDs in here, or you can put different categories in here. So say we don't care about anything that has shellcode to do with it. We would just put in custom shellcode like down here. Right now we don't alert on any stream events or Suricata ICMP v6 events. So like I said, you can put individual SIDs, you can put multiple SIDs, you can have a huge list of SIDs that you don't want to alert on because they're just showing false positives, or entire categories that you're not really concerned on. Maybe you're not concerned with it alerting. It'll still log it, you just won't be alerted on it when it pulls down the rules. So that's really your blacklist. You also have this modify SID. I'm not going to go too much into that, but this is basically if you want to modify an existing rule, you can do that in here. Generally, it's better practice to just disable the rule and then rewrite it and put it in your local.rules file with whatever you appended or changed in that rule. One last thing I wanted to go over with Suricata is in the rules file, this threshold.rules right here. So what the threshold.rules does is it sets thresholds on Suricata rules. So let's say we have a Suricata rule that we don't care about if it fires off of a certain IP address, or we don't want to get DOSed with alerts, or we want to filter it based off of source IP, destination IP, based off of a certain time amount. We can do all this through the threshold.conf file. So for example, it gives you some examples down here. You would put in, let's just say, for some SID or rule, Suricata rule, we would want to suppress it if the source IP was 10.1154, because it's just throwing a bunch of false positives, and we don't need to do it. You can suppress it by CIDRs. You can also suppress it by time. So let's just say we don't want a certain rule firing 10,000 times in 5 seconds. So we can do, a rule type here. You don't have to do it by source, but it's only going to fire one time every 60 seconds. So you can set that to like 500 seconds or once every however often. But this is useful for just whitelisting IPs for alerts. So let's say like, like a I don't know, some kind of DHCP keeps alert or a DNS alert keeps firing because something keeps making DNS requests. Well, that's a domain controller. So we can whitelist that domain controller based off of whether it's a source IP or the destination IP. Or for example, if you're just reaching out to like Google DNS, like Quad 8 or Cloudflare Quad 1 or IBM Quad 9, you're going to whitelist all of that here for the rules. So any questions on Suricata? That's like the big overview on Suricata.
Yeah, I just had one question. When we were talking about Kibana and you were trying to pull the Kibana logs for Suricata on there, either I misunderstood or you said when you go to do that, it's still going to be listed like it's a snort log.
Right. So that's because so the way it was originally built, Snort originated before Suricata, and it took a while for Suricata to get off the ground and develop traction, and for it to for the developers to develop all the features that it now has. So when Doug was building the parsers for all of these logs, everything was on Snort. So instead of him having to go back and change all of those log parsing and everything that is referencing Snort, which is a large task. Really only Doug and a couple other people maintain it, Security Onion, on a regular basis. So that's a pretty large task. So they left it on event type Snort. You'll know which one you're running when you go through the setup, whether you're running Snort or Suricata. So even if you do event type Snort and you're running Suricata, that's fine. You're running Suricata. So it's basically they haven't gone through and changed all of those parsers and input log files from Snort to Suricata yet.
So it's really just a matter of them not wanting to change that because it would be a big overhaul in their limited staff.
Exactly.
It doesn't, Security Onion doesn't actually have a preference, like it doesn't prefer Snort over Zericata, like there isn't
No,
a,
not at all.
okay.
That this is just legacy parsers that haven't been changed from Snort, and Doug hasn't developed any scripts yet to change all of those from Suricata. And when you actually get more into the file system, you'll realize how big of an overhead task that is. It'd probably take them, him and the limited team, a long time to just focus on that, and they're still wanting to push out like feature updates and things like that that they get from the community.
Yeah, no, absolutely. I just want to make sure it didn't actually have a preference on which one you ran, if there was a
Not
reason
at all,
for
not
that
at
or
all.
anything. Awesome.
I would
Thank you.
always, and even if you're not running Security Onion, I would always prefer Suricata over Snort now. Maybe not like 10 years ago or 5 years ago, but to where it's at now, I would definitely go with Suricata. And here you can, write Lua scripts to do other stuff. I won't go into that, but you can read more on the Suricata webpage. So Bro, everything for Bro is in the opt Bro directory. And so just how Suricata operates off of signature-based rules that were pulled down on the ET, your signature-based rules being these, Bro operates based off behavior-based scripts. All of these scripts are under, like I said, Bro scripting language, which is very, very similar to Perl. And all of that is in the now Zeek homepage on how to write Bro scripts and different variables and all that type of stuff. I won't go over that because that's another beast. I'll just cover some high level things. So one of the files that we really look at for the configuration is an opt-bro, and all these file systems are on that initial page for the directories down here. Opt-bro, share-bro. This is the example. So you can see how they're kind of changing everything from Bro to Zeek. Local.bro is now symlinked to local.zeek. So they're kind of changing everything from .bro to .zeek, but realizing a lot of people are still on, used to like .bro. They just made everything really like a symlink. So I'll cat the local.zeek file. So this is where you can disable, enable different scripts for Bro. You can add, there are a ton of different scripts uploaded by the GitHub community that will detect a bunch of different things that you can look through at your leisure. But by default, Bro will alert on capture loss, basically like OSAC would, like there's no data coming through the wire on your sniffing interface. So it'll detect scans, trace routes, vulnerable software, version changes to software. So if somebody updated from like Firefox 68 to Firefox 70, it'll track the version change in the browser, detect Windows shells, a bunch of different types of protocol software, FTP, SMTP, SSH, and the likes, different web apps. You can see all that through here. It'll do asset tracking based off of IP address, certs, services, do cert validation. So if like an SSL cert is expired, it'll throw an alert. If it's self-signed, it'll throw an alert. Interesting host names, I'll go into some of that. It'll detect SQL injection. It will hash all of the files in SHA-1 that it does extract, so you can run that against some kind of like hash registry, like Team Cyber hash registry, to see if it's malicious. Heartbleed, it'll detect VLAN logging to see which VLAN is on if you're doing 802.11q. It'll detect MAC addresses. Here's your file extraction. It has Mandiant APT1 detectors. JAW3, it fingerprints SSL clients since more things are going to TLS and not plain text anymore. Same thing with like hash. So there's a bunch of different types of scripts that you can get off GitHub. These are ones that are just and write yourself. These are just the ones that are included with Security Onion. I'll show you a couple of example ones. By default, Bro is not an IDS in the same way that it reports things based off of severity. It just reports it off of Bro notices. And I'll show you what I mean by that. So basically in Kibana, instead of reporting high, medium, or low severity, It just has your bro notice. So anytime bro throws an alert, it's called a notice, and it's not ranked. There's no ranking. Everything is just a notice alert. That's what these are. I don't have any in my network. Good thing. But I'll go into what an example script would look like. So for example, there's a script here, a Zeek script. So Zeek is behavior-based detecting based off of scripts. So let's see what how Zeek would detect brute forcing. So I'll cat the detect brute forcing script, and this may look like a lot at first. So this is relatively similar to Perl, if you've ever created anything in Perl. But basically what this is looking for is if there are 30 failed SSH connections in 30 minutes, throw a notice that there is potentially SSH password guessing going along. These are variables and can obviously be changed. So if you want to do 30 attempts in 5 minutes, 30 attempts in 1 minute, 100 attempts in certain times, you can do that, adjust it as needed. So what we did, something at Soteria, which was really cool, and more people are doing this now, so I can kind of put this out there, to make it synonymous, kind of with how Suricata works. We assigned it, we turned it into an IDS alerting system, meaning we assigned it a 1, 2, or 3 for high, medium, or low, instead of just notices. So what we did that is in the notice section here, we actually appended just a random variable like so called n for notice, and set that equal to 1 for low, 2 for medium, and 3 for high. So we put that in there, and we went through every single bro script, which there's a few dozen by default in Security Onion, and appended a value of a variable n to the notice framework. So what would appear in the front end is what we built, a dashboard of basically all high alerts. So for Suricata, basically anything that comes in with a class type that is associated with high alert or a bro notice that has a variable of n equals 3. All of those are our bro and Suricata high alerts. And you could do the same for medium and same for low, because by default, it's just going to do a notice. There is no medium, high, low severity by default, but we put that in there to kind of make it a alert-based notice instead of just notice. So when you do see this notice pop up, it will say there's a variable s, which is just for the host, which will pass in an IP address. And so the IP address appears to be guessing SSH password. Seen in this many connections, the variable being d up top. It will pass in the host name, the number of connections, and some other identifiers in the actual log. And then n would be the variable that we put also in this log for 1, 2, or 3. That's kind of how it works at a high level. There's a bunch of different ones that you can find out there. I'll just show you one more, which is interesting host names. So these are all under the SSH protocol, but essentially what this one is doing is saying if anything is logging into an SSH server, so if the client has a host name with any of this regex in it, so if the client host name is like SMTP 0 through 9 star something, that's kind of interesting. Why would you be logging into anything like that? It's just suspicious. And you can obviously append this, edit this to more or less, and then it would throw an alert in the notice field, possible SSH login involving this host with this name, interesting host name, and include the local remote. And then, like I said, we included like we would put like a we would assign this a medium severity, so we would put like $n equals 2 for this, for a medium severity. So all the bro scripts are stored in opt bro, share bro, and they're kind of distributed throughout that. And you can put in your own custom scripts. And then anytime you make a change to bro, you have to restart it like you do Suricata. Very simple command for CTL. Or I'll just use the new one, CTL deploy. And it's actually really cool what this one does. So if you have a suricata rule that you didn't write correctly, or if you have some kind of syntax error, like an extra white space or a unknown character or something like that, suricata will just, it won't tell you, and will just restart and it'll just disregard that rule altogether. Bro actually, when you do a deploy, it actually checks all of your configuration files, all of your rule files, everything like that for syntax errors. And if it does find one or some kind of invalidation in the rule, it will actually not deploy. It will say, for example, I'll edit that file and put something random in there that doesn't make sense. So for example, if I just put in at this, actually it's not going, I'll just do, so just $n up here randomly, and then try to redeploy. It will tell me there is a syntax error in that file at or near on line 8 at or near this expression on that line. So that's pretty cool. It'll actually do Zeek will actually do all of the syntax checking before it deploys and tell you if something is broken in your script and where it is broken. And then when it's all good, you know, because it will just deploy as normal. Like I said, Bro also extracts your executables and stores them in a directory. But for PCAPs, so this is also on that that web page where these are stored. PCAPs are stored in NSM sensor data, and then whatever sniffing NIC you're on. So in my case, it's just seconion 2, daily logs, and this will store and rotate PCAPs on days as well. So if I go into, for example, yesterday, I can see all of the PCAP files that were yesterday. And since mine rotates on size instead of time, I can do a du tech sh and get the size. That whole file is only 2.2 megs. So and it rotates based off of 150 megs. So it might be good for me to tune down that 150 megs to rotate on like some fraction of a meg, or rotate like every 2 minutes instead of 150, because I only have 2 PCAPs in there now. All of the PCAPs will be stored as snort.log.something. This is where that snort variable is still in there. But these are just PCAPs, and these can be viewed in Wireshark, TCP dump. For example, I'll just show TCP dump, stack r snort.log 159, and this shows via TCP dump the entire PCAP. So that's where they're stored on disk. To go back and view, you can go back, with my file system only being at 3%, this will store months worth of PCAPs since I don't have a lot of data traversing my network. But on obviously busy networks, it'll be more PCAPs, more PCAPs in files than that. So, any question on Bro or the PCAPs?
No question, Anthony. Although I just want to let you know it is 12:09.
Yeah. If anybody has to like jump off or anything, I can cover OSEC, or I can just stop here. It's up to you guys.
What was OSEC again?
OSEC is the host-based intrusion detection system, similar to kind of how Suricata and Bro work, except it's on a host-based level. It's not something we really have to cover here. We can just open it up to Q&A. Most security onion distributions are going to be for your network sensor services that we covered. I can skim over OSEC real quick.
I think we'll go Q&A just for time's sake, for the recording as
I
well.
think it might be best too, Anthony. Maybe it doesn't have to be next week, and whenever you want to, and then you have the time, maybe we will also open up like a second session of you starting off with OSEC and stuff like that, you know.
Yeah, I think that would be good. Obviously, this is a very wide, robust product. But yeah, I would like to go further down the rabbit hole of this in the future. I think it'd be great for everyone.
Sure. And yeah, so OSEC is kind of a different beast on its own, since it is host based, and I think it would definitely be better to do it on a different Saturday because we can show how to deploy the agents to different machines on a network and how they communicate back, and then fill those logs. So yeah, we can definitely do that on another Saturday.
Yeah, that sounds like a great activity and demo.
Yeah, so with that, I'll go ahead and open it to questions, comments, anything you guys for references on additional tasks, or if you want me to cover something else in depth.
I'm curious, you know how like in Wireshark you can just take PCAPs and you do the file packet analysis, right? Is there a way to like dump like practice data or maybe old data into like a freshly built security onion stack and for training purposes, so that way you could have people come in and practice against like a full set, like it's fully populated. Does that make sense?
Yes,
that video
and
that I
great
sent
question.
I
So
saw that.
Security Onion does have sample PCAPs that will contain different types of data, both like malicious and non-malicious, just like regular types of traffic, for you to be able to go through and do that on. So this link here walks you through how to do that. Security Onion samples. You can also just go on GitHub, and there are a ton of. It doesn't have to be just through Security Onion, just any kind of sample PCAP that you can download just through like a wget on the file system. Uh,
Yeah, I just wanted to have something.
there's definitely mock PCAPs that you can just run through on the file system. My network's probably blocking this on the system for just regular analysis without actually having to load anything in yet. Here's some samples right here. So yes, can do that. And actually, this one gives you an example PCAP based on what it's doing. So Tor, Bitcoin, blah blah, just for learning practices. Yep.
Awesome.
And that's just pcapanalysis.com. So pretty straightforward.
It's not PCAccessPointAnalysis.com. No, it's just making a very bad joke.
Oh, I got you. Yeah, I'm sorry, I didn't catch it. Yeah, I know we definitely covered a lot today, and it could be intimidating at first, and definitely is. Like I said, Security Onion is something that you can easily go into just weeks and weeks of just learning on before feeling comfortable in a production environment. I've worked on it when we were back building it just day after day for months and months and months. So that's what got me familiar with it, and that just after working for with it for so long, that kind of information just kind of sticks. So best advice I can give you is even if you don't have a managed switch at home where you can set up port mirroring or something like that, just going through the setup process and importing PCAPs like test PCAPs and feeding those in will obviously help. You can obviously set up like HIDs on your home laptop with Security Onion being the HID server or the OSEC server, but just be comfortable with traversing the dashboards that are on here, getting used to where things are located on the file system, getting used to commands, really the stuff that's on the cheat sheet, so that when you do go into a production environment or if you do talk
with someone about it, you feel like you're more knowledgeable and you feel like you have a better understanding rather than just jumping right into it off of the bat. So the cheat sheet is always a good resource, and there's tons of different resources out there, especially on GitHub for people that contribute to this that you can plug in. That we didn't cover today, but yeah, there's a ton of stuff out there.
Anybody else?
Anthony, I have one question. So you mentioned only, I think when you're talking about pulled pork, that there was a cost associated with that. Are there any other costs associated with things that would be really important, that you'd advise people to pay for, be it support or extra functionality in the whole environment?
So by default, and that's a great question, Pam, is when you install Security Onion, everything that you're going to everything that you install is free and open source. So definitely don't. So anything under the GNU Linux license is free and can be distributed, and it has to be free. So that's the reason Doug couldn't bundle up Security Onion and sell Security Onion as a product, because it's an Ubuntu fork. So he can only sell professional services around Security Onion, and he can sell hardware that Security Onion is installed on, but he can't sell Security Onion directly. So everything that you're downloading is free. Everything is free, including the ET Open rule set. The only thing that setup, the Security Onion setup GUI even offers you to pay for is the Emerging Threats Pro rule set, which is through Proofpoint. And even if you selected that, it's not like you would just inherit a charge. You have to contact Proofpoint and say, I want this pro rule set, and then they'll have to email you that OINC code, that just random string of letters and numbers, like any other activation key. So even if you selected that, it just wouldn't work. It's not like you're signing up for something off of the bat. Off of this. So Doug configured it so that you wouldn't be inheriting a cost by default. So other than that pro rule set, other services that are surrounding that you can get paid. Obviously, there's conferences around Security Onion that you can go to learn more about it. But Doug runs a Security Onion solutions site and services. I think it's actually just Security Onion Solutions. So with Security Onion Solutions, and this is Doug's paid, basically paid training, professional support. So you won't get additional functionality. The only additional functionality you really get is out of that pro rule set. Really with this and other services offered or other companies offered as well. But you're just getting enterprise support and training, and people will come on site to set it up for you. But there's not like an additional feature set that you're gaining out of like Security Onion and like a paid thing. You're just paying for the professional services, installation, and support that you would be getting. The only thing that you could potentially pay for is if you didn't want to source your own hardware. They sell the Security Onion Solution sells hardware that would be best suited for what they feel like your environment is worked on. But if you want them to come in there and do a paid professional services, they'll do the tuning for you for your NIDs and your HIDs. They'll do the support for your hardware. They'll do your deployment. They'll do your architectural planning. So it's really for the professional services that surround Security Onion, not for any other feature sets.
Okay, thanks.
Anthony, thank you very much for a very in-depth overview of Security Onion. I think maybe the best way to go about this is, do more follow-ups. Take one session to explain one or two things, so we can actually get really deep into everything. And I think you did fantastic in the last 2 hours. I think you did a really good job explaining what we talked about yesterday. But I'm sure there are some students who want to know more about a specific feature or specific way to monitor and whatnot. So it might be best to do more follow-ups if you would like to, and focus on one thing at a time for some of the other students.
Yeah, definitely. That's something for, everyone to think about, especially everyone at Trident. I would, like I said, just recommend just spinning up, a security onion. You don't have to be capturing any traffic. Just get used to the tools that are on there, and kind of see where your comfort zone is, where you're having trouble, where you're not seeing as much resource on the web. There's a lot of different things that you can integrate with Security Onion that I didn't go over today. I just want to cover with it, by default, but it does have stuff like Google Rapid Response for IR that is easily integrated with it. The Alien Vault Open Threat Exchange can be integrated with your rules. There's Stroke file scanning. There's a lot of things that can be implemented that, like I said, you can just spend weeks covering all this stuff before you even start deploying it. So I would, definitely recommend doing that. And then, whatever came out of today, just pick which topics you'd like to spend more time on, whether it just be Suricata or just Bro or just OSEC. We can spend, weekend sessions like this on just those technologies.
Sure.
That's probably the right way to go
Yeah.
about this for sure.
Yeah, or
That'd be pretty
or
cool.
even going over using the dashboard for
Yes.
the Kibana dashboard, in which you would actually go through as daily as a security analyst using Security Onion. What are the things you look for? What are the things, where would you find it in there? So, I mean, I know you went over some of it, but it would be cool to get very versed on that part if we're going to actually go into the business for that.
Yeah, I think what might be pretty good is if we have everyone go through like who wants to do it down like install and set up maybe the evaluation version or something. I don't know, and then pull in some of the PCAPs that have malware and stuff in it or whatever, some type of intrusion, and like go through like an analysis because that'll step you through, right? That'll step you through parts of the dashboard, right? And then people could follow along.
Right. And yeah, that's a good point. And it's really when it comes down to the malware analysis type stuff for the network part is how to pivot from one dashboard to the other without kind of going down a rabbit hole of dashboards. What data is going to be useful for this alert or event, and then being resourceful on how to pivot to other log information, log sources or information sources or other dashboards that will take you to the next step and being able to, determine whether that alert is a true positive or a false positive. That's kind of an art in itself.
Oh, that would be great.
Yeah. All right, and then I'm gonna
I didn't go through
pin
this,
it.
but you can actually pull the raw PCAP through Kibana based off of the log that you're on. You can just say, maybe I need to look at the raw PCAP for this information. Maybe I want to get header information. Maybe I want to see the actual GET request and it's not in the log file. So you can actually import the log file through Kibana without having to go through the file system. That's really useful. I just didn't have time to cover that today.
Well, sounds like we've got some plans for the future. I mean, this was fantastic. I really appreciate just having the ability to have access to your knowledge base. I mean, it's incredible. Like, I don't want to tell you could charge for some of this stuff, but because I like getting it for free right now, but you could definitely you have a good presentation style. You could do this on the side.
And what we're doing, I'm acting on behalf of Soteria. We're looking to get more involved in the community, and we have been. But we always like reaching out for new opportunities, especially guys, and girls like you who are very obviously passionate about cybersecurity to be taking, now on, 2.5 hours on a Saturday morning to learn about Security Onion when, a lot of the people have, want to live their life or whatever, So you guys are obviously dedicated, and that's what's missing a lot in cybersecurity is just, passion for the job, and that's much harder to find than, knowledge. Knowledge really isn't that difficult. Anybody can really just go learn something, but it's to actually get somebody to go do that and want to have passion to do that and want to have the passion to learn. And then when you do learn it, you want to give back to have other people be able to give that knowledge. So that's why we're always able to do that. And I opened it up the last time I spoke here, but I'm always free to reach out on LinkedIn or available on Discord to whatever subject. Doesn't have to pertain to just even cybersecurity, networking, anything in STEM. I'm just like a STEM nerd, so I'm always available for that kind of stuff.
Well, we certainly appreciate it. and maybe you end up with some good quality employees out of it.
We got Brandon out of it.
Yep, you already
That's
got
the
one.
main objective. There's definitely some good people at Trident. I just don't quite think that they know where exactly to go, and that's why I kind of brought Anthony in because he was in our position, I mean, not too long ago. So
Well, we 100% appreciate it.
I appreciate you guys jumping on, and I'm sure Brandon will coordinate something in Discord for the upcoming weeks.
alrighty, guys. Thank you very much, Anthony.
Yeah,
Appreciate it.
Chad, you have the recording session.
As soon as I get it, I'll put it out on Discord for you guys.
Sounds great.
Thanks,
Well, I
guys.
hope
Appreciate
everyone
it.
has a great weekend. Reach out to me whenever, and I'll see you guys next time.
Thank you,
Again,
guys.
thank you so
Anthony.
much, Anthony. Appreciate it. Definitely.